So the very next thing we should learn is how to write functions. For example, if you want the function gx equals x times cos x plus 5, then this is how you do it. I'll write stuff in my code.r itself. So I'll write g equals function x. So after that I'll open second bracket and close like a second bracket, and anything in the function I'll write within these two brackets. So for example, I'll say y equals x times cosine of x plus 5, and then I'll return y. That's it, done. So note that we start with the name of the function g, then we'll write equal to, then we actually write function, then within first brackets there is the input variable, and then we'll write y equals the actual number that we have, like that we should be computing, and then we return y. So let me save it, and let's not run the whole my code.r. Let me just copy this part and run it on the console. So now my g is ready. So for example, what's g of 1? It's this. What's g of minus 4? Is this. That's all. That's how you do it. So suppose let's look at a more complicated function. Say fx is x squared if x is less than 0. Fx is x times sine of x if x lies between 0 and 10, and it is x cubed minus 7 if x is bigger than 10. So we'll obviously start out with f equal to function, the input is x, and then we'll type stuff in. So now I have to check x lies where. I'll do that with the if-else statements. It's like if x is less than 0, then again second bracket opens. Then I'll say y is x squared. Else if x lies between 0 and 10, but the computer is stupid, so I have to tell it in parts. So else if x is bigger than equal to 0 and x is less than equal to 10, it will be y equals x sine x. So x times sine of x. Otherwise, else y will be x cubed minus 7. That's it. And then we return y, and we are done. So check, like, make sure that this else if starts just after this bracket. Like, this is not good. This is not good. You have to just start else if after this one. Like, this one is for this if the opens and it closes here, and just start after that. Similarly, this else start just after that. And also note that you didn't have to check the condition x bigger than 10 for obvious reasons, that x less than 0 and x lies between 0 and 10. If none of them happens, then x is obviously bigger than 10. And that's it. So for example, let me actually copy and paste it. Copy the function and paste. Like, if I don't paste things and run in the R console, like, it's not there. Like, I have to actually run it. So I copied it and pasted it here, and then I press enter, and then it's inside. So now if I want f of 2, that's that, which is like basically 2 times sine 2. If I want f of minus 4, it should be 4 minus 4 squared, so 16, and it is 16. If I want f of 11, it should be 11 cubed minus 7, which should be 1324. That's all. Let's look at another example. So suppose we want a function called quad. What does the function takes in? It takes in 3 numbers, a, b, and c, and then it returns something. So basically what I want is, I want to solve the equation ax squared plus bx plus c equal to 0. From high school we know the roots are x equals minus b plus minus square root of b squared minus 4ac by 2a. And of course, if b squared minus 4ac is not positive or 0, then this has no real roots. So inside here, all these things should be happening. Like, if it's not possible to give you real roots, that it should tell you, and if it's possible to give you real roots, then it will do that. So let me write the function quad. So quad equal to function, it takes in a, b, c, and then first of all we compute the d as b squared minus 4ac. If d is less than 0, then there are no real roots. So I want the computer to print out print there are no real roots. And let me print a new line and we'll get out, and I'll just do return. Sorry, and I'll return nothing actually, and that's it, done. If that doesn't happen, then we carry on. So the first root will be x1 equals minus b plus square root of d, this whole thing divided by twice a, and the second root will be x2 equal to minus b minus the square root of d divided by 2a, just as we want. Now let me do another version of the print function. This is the cat function. So let cat the two roots are, so let me give a space. The first one will be x1, and then I'll say and then the second one will be x2, and then I'll print a new line and get out. And in this case also, let's not return x1 and x2, just print stuff and get out. If we want to return, we can do that too. So let's save the file, and okay, it seems as if it's ready. So for example, if I want suppose x square minus 4x plus 3, that's actually x minus 3 times x minus 1. So its roots should be 3 and 1. So let me do quad 1 comma minus 4 comma 3. And the roots are 3 and 1. I'm sorry for the null, just a second. Okay, because I told it to return something, it did the null. Let me comment it out. I should not do that again, but let me do that. Let me again run the function. Yeah, so it was printing null because I returned nothing. So it printed null, that means nothing. So let's see some place where it should have imaginary roots. For example, obviously x squared plus 5 equals 0. That means a, b, c are 1 comma 0 comma 5. So quad 1 comma 0 comma 5, there are no real roots, and it returns null because we returned from the function.